So I finally finished writing up a multiplication program, so I thought I'd give you a little demonstration and try and explain how it works. So with multiplication, there's quite a few more steps, and so it actually takes a lot longer. So to start the multiplication, we have to load the program. So multiplication is located in program F, step 1. So if we run that, and then we'll have to input the A register, and that will make that 10, and we'll enter that, and we're to load the B register, and we'll make that as well 10. And it will start to go through the multiplication loops. There are 3 major loops involved in the multiplication program. The first one is to check some flags, and then it goes into the shift add loop. So here's a quick demonstration of how the multiplication works. First we have to load program 15, step 1. Run that. And now we have to load the A register, and we'll load that with a 10. And then we'll load the B register with a 15, which is F. And we'll run that. And so now it's going through, and you'll see one of the things it's doing is it's shifting out and shifting in zeros. And then it is also saving it to the stack memory. Once it finishes going through all of the shift loops, it will then go into the add stack loop. And once it finally adds the stack together, it'll output the answer, which is 150. To explain how the multiplication works, I've written it all out on a step-by-step program sheet. And so the way that multiplication works in binary is very much the same as multiplication in decimal. And you need to load the A and the B register, which is the first part of the loop here. Once you load that, then it's got to set the stack pointer so it knows where to save the information. The next thing it's going to do is it has to check if A register is equal to 0. Because anything times 0 is always 0. So if the A register equals 0, it'll automatically jump down to the 0 loop, and it'll output it back into the start, displaying a 0. But if there's no 0 present in the A register, it goes on to the next flag check, which is to check if the least significant bit, which I've called the AND1 flag, is a 1 or a 0. So it checks if it's a 1 or a 0, and in this instance it's a 0. So what it'll do is it will skip down to the shift out zeros. I call it the multiply shift. And it will shift out the 0 on the B register, and it will shift in a 0 on the A register. It will jump right back to the top of the loop, and it will check again for A register 0, which is not going to be, and then it will check for B register and 1 flag. And at this point we've shifted out the 0, and we have a 1 present in the least significant bit. So what it'll do is it will now save the A register only into the stack memory, and it will once again jump back to the start of the loop. So it starts back at the top, and it checks the A register for 0, and then it will check the B register least significant bit for a 1 or a 0. And in this instance we have a 0 again. So what it'll do is it'll come down through the loop, and it'll shift out a 0 and shift in a 0 to the A register and jump back to the top again. So now it's once again checking A for 0, checking the least significant bit of B for a 1 or a 0, and now there's a 1 present. So with a 1 present, it'll now save the sum of A register into the stack again, and it will go back to the top of the loop. So now we'll check the A register again, and then it will check the B register for the least significant bit, 1 or 0, and it is a 0. But now it'll check the B register if the whole thing is 0, equal to 0. And once it does that, it knows that it's time to go into the add loop. And when it goes into the add loop, it jumps down, and it has to set the stack pointer, and it will save a 0 to some memory. And this is basically the display. This is the final output. So it starts with a 0 and loads that into A, and it loads B from the stack, and it'll simply add those together and save that into the sum memory again. And it'll keep looping around, loading A from memory and B from the stack until it has added everything up, and it checks that by just comparing the stack memory to the saved memory, and it will just subtract and check for a 0. And when it finally reads a 0, it will loop around and it'll display the output. So I'm just going to multiply a few more numbers here just to demonstrate. So we'll do, let's try 200, which is C8 in hexadecimal, and load that into the A. And in the B register, we will load FA, which is 250. So we will load 250, which is FA, and we'll run that. And 200 times 250 is 50,000. So it is checking the B register and loading the stack memory. When the B register reaches a 0, now it'll change and go into the add cycle. And that's what it's doing now. Every time you see the B register flash with a bunch of 1s, that's checking if the stack is 0, equal to 0. And we get a 50,000.